was 1997. I was thinking it was the 80s. And it was 1997, so you did have a calculator handy on that problem. We'll do it almost all without a calculator. In the last 2 years have been the parachute problem. Last year was the bird problem, and the year before was the waste problem. And they're all exactly the same, except for some of the other little parts. Even the subparts from the last 2 years were the same. We're going to write these down because you guys should know how to do these, right? These are derivatives. So the derivative of e to the x is e to the x. The derivative of a to the x. A to the x times my name, lna. Okay, it's missing the name. You know, if you write my name, you still might get the point if it came out to it. Okay, what's the log of x? Natural log. 1 over x. How am I going to handle this one? Because I never memorize it. I'm going to do a change of base, the natural log of x, over the natural log of b. So the derivative is going to be, well, 1 over the log of b, that doesn't change anything. It's just a constant. So I take the derivative of the log of x, which is 1 over x. Now, if you think about it for a second, a to the x is an exponential. A log, if you make that base a, so it's similar to that, is the inverse of that. So if a to the x times the log of a, then its inverse would have to be divided by the log of a. Does that help at all to remember it? My word of advice is that when you walk into the exam, you write down some of these things. Grab one of each of those. You write down these things that you're going to forget or that stress you out. And you say, oh, I just don't remember that one. You know, write down things really quickly, just like we're doing now, and you have it. And then you can go back and refer to it. It just takes some of the stress away. And the other thing is I would graph the sine curve and the cosine curve. So you quickly have values for the sine of pi over 2 and the cosine of pi over 2. And I would also draw in my 30, 60, 90 triangles and my 45, 45, 90 triangles. Okay, what about this next one? What's the derivative of e to the f of x? Yeah, that's just the chain rule. So if you want to integrate a composite function, you have to see the derivative of that inside function. You've got to see that under that integral. Okay, and the u substitutions are what helps me figure out if it's there or not. What about the derivative of a to the f of x? A to the f of x times the log of a times f prime of x. And I better change colors because these will run together. Okay, what about this one? The log of f of x. It's 1 over f of x times f prime of x. Okay, Noah, Alex, you really need to be focused today. Next week, we have 2 days of review and test, so there's nothing coming new next week until Friday. What about this one? It's 1 over the natural log of b, because it's just like this, times 1 over, not x, but f of x, times the derivative of that. Is that okay? And the next problem that we're going to do is critical. On the exam, there are 10 questions on the multiple choice that are repeated from every year to every year, which is why I don't get to see the multiple choice exam every year, because they like to use the same questions again. So we have them for 4 years. We have 97, 98, 2003, 2008. It could go further back. However, the flavor of the questions isn't the same. So it isn't going to help you to do those. But it really helps you to do really well in the 2003 and 2008. Even the change from 97, 98, there's a significant change there. But 2003, 2008 should give you a good feel for what that multiple choice exam will look like. Well, one of the questions that's repeated is this one about these differential equations about this population increase. So we have to recognize it when it happens. It'll be in a different form. I've given you lots of problems over there, multiple choice problems, off the old exams where you can see the problem. And I can say, this is the same concept, same problem. just changed a little bit. Okay, what this says, it says the rate of increase in the population. What is a rate? What is a rate? To know this, it's a derivative. So they're saying the rate at which a population increases only during a short period of time. It doesn't go forever. So this is a derivative. So how can I write that derivative? It's the change in the population as what changes. All right. Doesn't make sense to make it x. Is directly proportional. Do you guys know what that means? That means that, and it's directly proportional to the size of the population at the beginning. So whatever the population wants to start with, the bigger the population, the faster the rate of increase. Makes sense? If you have a little population is not going to grow very quickly. If you have a big population, it's going to grow quickly, which is one of the problems that we have in the world. In Egypt alone, there's 89 million people. In Cairo, they have 20 million. In Alexandria, they have 16 million. Egypt is not that much bigger than the state of Minnesota, and we have maybe 3 million people here. So population is increasing quickly, and it looks like this. You've seen this. It's an exponential growth curve. And why doesn't it work for long periods of time? Because you got a problem here, don't you? What's going to happen? And it's happening some places. They don't have enough food for people. You run out of resources. You run out of space. So what it really has to do, it has to increase for a while, and then it has to level off. It's called a logistic curve. We don't have to know that in our class, but you've seen it. You've seen it actually more often than you realize. So we're just going to do the short period of time graph, which is this, which is an exponential. And the derivative looks like this, the formula here, and they might give it to you in a word problem, like this. The derivative, the rate of increase, is directly proportional to the population. So it's a multiple of your population. K is a constant. If you work at an hourly rate, then the amount of money you make is directly proportional to how many hours you work. More hours you work, more money you make, right? That's what directly proportional is. Now, why is that important? Because I've seen on the AP exam a question that says, show that this is directly proportional to this. This K is called the proportionality constant. And they would ask for that. What is the proportionality constant? If you don't know what it is, how can you answer the question? Right? K equals proportionality constant. Hi. I ran more because I don't have any of those. So, more of the parachute problem. So they might ask you for the proportionality constant. That's what they're saying. It doesn't happen very often, but when it does, it's kind of frustrating for you. Okay, we're going to solve this differential equation, and I'm going to rewrite it here. And we know how to solve differential equations. This is one of the most important ones. We are going to do the parachute problem, and it's exactly the same kind of equation. Last year, we had a bird problem. Same kind of equation, solves exactly the same way. And the waste problem, exactly the same way. Then other ones will look like this green one, where they just give you some sort of dy dx and you separate the variables. Although it's the algebra that gets us in trouble on the very last point. Because remember, what's the first point doing? Separating the variables. So I don't like a fraction, so I can at least do this. It won't get me a point yet, but what do you want to do to both sides? Multiply by what? dt. Problem is, I have a p here and a p there. In fact, what are our variables since I'm talking about it? What's the input? No, it's the what? It's the time. As time goes by, we measure what? The population. Now, we're only measuring the growth. We're not measuring the population itself. And that's generally speaking, if you go into your science classes and you look at what you measure, it's always a derivative. It's always how something changes over time. So if you go in for a strep test, they look at the bacteria growth, the growth rate. They don't have a function for the bacteria population as it is. Well, it might have modeled it with some mathematics. Okay, so when the time is 0, what would you like to call your population? Well, let's give it an initial condition. Then they're all done the same way. How about initial population, P0? Does that work? some number. I don't know what it is. Okay. What's the only thing I can think of to do? Zach, what do you think you can do here? No, not yet. Got to do some calculus first. But you can't integrate it because this letter's here and this letter's over there. We have to separate our variables. So only thing I can think of is to multiply by dt equals k p dt. And I know that when they did the waste problem, the kids came to me after the exam and said, "There's no t's." I go, "That's okay. There are no t's in here except for dt." So what's the one that's got to get out of here because it's in the wrong place? P. So we always multiply, divide to make that move. Can't undo adding. So we are going to divide by p. So you check, are the variables of the same kind? You have to write this down here so you know what the variables are. Do that because we had a waste problem with time. And you'll see it. Okay, so I have this. dp over p is equal to k times dt. I separated the variables. I got my point. If you don't do that and you try to integrate right away, you're going to get 0 out of 5. You're going to get 0 out of 9 because on this year, this problem, if you didn't get the first part right, it's very hard to get the rest of it right. I'm thinking of the skydiving one. In this case, this is just 5, so we're doing a differential equation. Now what do we do? Step 2. How do you get rid of derivatives? Integrate. Now I'm going to go at that k is a constant. I don't know what it is, but we'll just leave it as k. There it is. Now, this really is 1 over p dp. Do you recognize that now, or do I have to go to this? 1 over x dx. They're dummy variables. We don't care what they are. What is that going to give me? Alex, what's that going to give me? This gives me the natural log of absolute value of x. This gives me the natural log of absolute value of p. Do you see that these are the same? I don't want that to bother you. If it's bothering you, tell me. You just have to rewrite it a little bit with a little bit of arithmetic. So this is the natural log of the absolute value of p. I know the population's positive. But there are other situations when you must have that absolute value there. So we're going to keep it there and get rid of it at the end when it makes sense to. So right now we're going to pretend population could be negative. And what's the antiderivative of dt? Remember, this is a symbol to integrate the 1. It's just t. It's saying the derivative with respect to t of what gives you 1. The slope of what? T. It's just reversing it. Okay, I got another point, by the way, but I'm not going to get any more points if I don't do what? Plus c. Must have it. Pardon? That's right. I must have the plus c now. If I do it later, it's wrong. And this, because these are exponentials and logarithms, is not a simple shift up and down. It's different. That only works for polynomials, like x squared. And even the sine function, it works. Okay. So we have our 3 points, which is very nice. And now we get a point for putting in our initial condition. So I'm going to put P0 in for P and 0 in for T. So it's the log of the absolute value of P0. I'm going to keep it there until I don't need it. And equals K, and T was 0 at that time. Does this make sense? If it doesn't, you need to tell me, yes. Because it's 1 over P dP. This symbol here says find the antiderivative of that, which is a logarithm. It's not a power rule. This is find the antiderivative of 1. It's a different function. What's the derivative of t with respect to t? 1. So I have to figure out, you could do guess and check. T squared doesn't work, does it? That would be 2t. So you're going to either memorize it or think through it, one of the two. Okay, can I solve for C? C equals the natural log of the absolute value of the initial population. Well, the initial population obviously is positive, so I don't need that absolute value. But be careful with it. It depends on the context of the problem. Here it's population. I know it's positive. We have a negative population. That was the initial conditions. In the beginning, at time 0, we'll say our population is some number, call it P0. They'll give you a number. I'm just doing this in general. We're going to see something that some of you remember, and some of you either don't remember or never saw. They should have, which, if not, I think we'll do it after the AP exam, because you should know about compound interest. Because this is the initial population. Yeah, makes sense. That's why they call it a natural domain. Okay, so let me get my answer here. It's right here. Well, it's not done. Okay, you guys, because I put these values in the right place, I got my point, even if I did it wrong. And it certainly doesn't hurt to keep the absolute value symbol there. It's not wrong. So if you'd like to keep it there, be my guest. It's the natural log of the absolute value of P is equal to K T plus the natural log of the initial population. When we do the parachute problem, you're going to see it's the same thing. It's exactly the same thing. And that's 3 years right off the top of my head that they've given this question. And sometimes when the kids keep missing the same thing, guess what the next year's problem is? The same thing, just like when we gave you the same quiz 3 times. Right? We're hoping we'll get it. It'll be different context. Who knows? I never can guess what they're going to do. I can tell you the concept that's going to be tested. But you know what? When we solve a differential equation, it's an equation involving derivatives whose solution is a function. I need to have P equals. That's what I have to do. So we have to get rid of that logarithm. Now, this is critical. How do I get rid of a logarithm? Okay, Zach? I'm going to exponentiate each side, not each term, because that's wrong. It's anytime you do something, it's always to a side. If you can remember that, and then you have to use your rules for algebra as to whether or not it applies to each term. This is e to this side, and it's e to this side. Okay, I've graded this problem 2 out of 3 years, and this is what they get wrong. I've seen it over and over again, and I wish I could grade my own, but I'd be curious to see if you get it wrong. Actually, I could go look at last year. We shouldn't, because we've gone over it. What is the left side here? E to the natural log of the absolute value of P. What is that? It's the absolute value of P. We're going to get rid of the absolute value soon. We're going to pretend the population could be negative right now. Then if you don't know what this is, just leave it like this. Because this is what I see. Does not equal e to the kt, because this is what I see all the time. That is not a true statement. This is equal to e to the kt times e to the natural log of the initial population. I'm just going to take a second for you to think about that. Because if you have e to the m times e to the n, and we're going to do a lot of this in BC, which is why I think the BC Calc students do better on this problem. It's equal to e to the what? No? If you have the same basis, what do you do to exponents? Remember, that's just 3. It's 2.7. But think of it as 3. You add the exponents. So you can't make adding the 2 exponentials because that's wrong. Distributing e to that, and it just doesn't work. You can't do it. Remember, exponents do not distribute over addition. So if you don't know that this is not this, then don't write that. Just leave it like that. You get full points. So if I solve this for P, there's 2 possibilities because of that absolute value. Whatever I put in here could be this e to the kt plus the natural log of P0. We're going to simplify that, though, because I want us to recognize this formula. Or whatever I put in there, I could put in a negative one, too, couldn't I? So it's negative. Now we're going to think for a second. Can my population be negative? No. So that's good. We get to eliminate this answer. And let's write this answer the way I would like to see it written. Although that would give you full credit, by the way, which is nice. So it's e to the kt times e to the natural log of the initial population. Can you simplify that last? What is e to the log of anything? What's e to the natural log of f of x? It's f of x because they're inverse operations. They cancel each other out, just like a derivative cancels out an integral and an integral cancels out a derivative. So p is equal to, well, that's just p naught. P naught e to the kt. You have seen it, maybe. P equals P naught e to the RT, where R is still just like K, but it's the interest rate. That's compounded. This is interest compounded continuously. If you haven't seen that, then I do think we need to do this after the exam. I don't believe they're going to have compound interest on the exam. But if you're going to go buy a car or buy a house, these are important things to consider. Okay, so how do you do that? And have you done half-life? In science, this is half-life. It's PERT. That's where the half-life formula comes from. It comes from this formula. Where does it come from? The differential equation. Now you see where things come from. So if I have I don't know why we haven't done velocity. If I have acceleration as a constant, then I can integrate that, and I get the velocity equals at plus some constant. Well, guess what the constant is? It's your initial velocity. If I integrate the velocity equation, I get s equals 1 half at squared plus b naught t plus s naught. Yes? Yes? Okay. 5 points. But look how much work it took to get to the 5th point. If you are pressed for time, you know that once you get the C value, you can stop. You're going to get 4 out of 5 points. You know, don't worry about it if you're saying, oh my goodness, I still have another problem to do. Go do the other problem. Because there's only 1 point for all of that work. And unless you have practiced this a lot, this is going to take you time. So we're going to practice. We're going to do the parachute problem. The classic parachute problem, which is the waste problem, which is the bird problem. And there is a typo on here, by the way. No, this should be, if you're interested, 1 half P naught, I should fix this, equals P naught e to the kt. Because those would cancel. That's your half-life. But now this last part right here, it has nothing to do with half-life. It has to do with PERT. You will have a differential equation that does vary proportional to the population itself. It may be disguised in the problem, but you will have it. We've got lots of sample multiple choice problems for you to see that, and I'll point it out on Monday and Tuesday. Because Monday and Tuesday, that's all we're going to do. If you want me to stand up at the board and do problems with you, that's what we're going to do. But let's go ahead and add a page. And see the white one about the parachute problem? This is 1997. So the answers are online. I was thinking they weren't. So it says let v of t be the velocity in feet per second. Now this one didn't care about units. They did put the units in, but they didn't ask you to put units in. So if you forget about units, fine. If you put units in and they're wrong, fine. Don't worry about it. We won't look at them. So you're better to put the units in than not. Because if the units are wrong, no big deal. Okay, my time is positive. And I have a differential equation. dv dt equals negative 2v minus 32. And it gives you an initial condition of v of 0 is equal to negative 50. And maybe it would be to our best interest to figure out what the variables are. It says, use separation of variables. Define an expression for v in terms of t. What are the variables? T and v. T is my input, my velocity is my output. I'll measure my velocity after a certain amount of time. What is this then as an ordered pair, my initial condition? This is function notation, 0 and negative 50. Will velocity be negative? Yeah, if I drop my pen, Velocity's going down. Can speed be negative? No. They're going to get the speed in here. Okay, and some of you are going to say, but you said that if you have an adding problem, which that is, even though it's subtracting, that you can't separate the variables. That's true. That's a true statement, x plus y. However, if I can make it a multiplication problem, maybe I can separate it. They tell you, use separation of variables. They don't lie. That means that tells you right away you can separate this. So first thing I'm going to do is multiply by dt. That isn't going to get me anything, but now I want to make this, because I can't add something. I have to multiply, divide, see if I can get things to the other side. Okay, Zach? Can I make that a multiplication problem on the right side? Obviously, if I'm asking, the answer must be what? Yes. What can you do with that? This is where you're going to get stuck. Factor out the negative 2. That's right. So it's v, watch your sign, plus what? 16 dt. Still don't have my point yet. Now I have a times problem. Here's my recommendation. Anything with constants, any of these constants, leave. It doesn't matter which side you put it on. But if you leave them on the right side, the independent variable side, the x side, you're going to be much happier. I can put the negative 2 on the other side. It just makes things a lot harder. Even I get them wrong. So then you really have to be careful. Well, what's the problem here? I've got v alone here. That's fine. I want dt alone. What is here that shouldn't be here? Okay. So how am I going to get rid of it? Divide. And the only way you get to be good at these, unless you totally get it, but probably you need some practice with this. So we're going to do 3 problems. I don't know. I just have a feeling, and sometimes I'm wrong, that they're going to give you one that is going to be just like this again. I don't know what the problem's going to be. And they write those 2 years in advance. I was really surprised last year when the bird problem was almost identical to the waste problem. And you're going to look at it and say, that's different. Well, when we go over it next week, you'll see. Okay, let me clean that up. That's a mess. And again, some of you don't recognize this. You know what? This is exactly the same question that we did dp dt. We had dp over p equals k times dt. That was the first problem I did today. What's k here? Negative 2. You can bring it over there. It's just harder. So I don't want to make it harder. And if I didn't have the plus 16, it's exactly the same, isn't it? You must show your calculus steps, by the way, even though you might recognize what it is. But think of that as a good check. But all this is a shift. 16 units to the left. It's the same thing. If you prefer to write it this way, maybe you'll see this better. We're going to integrate that. By the way, I got my point. What's this going to give you? Yeah, natural log. 1 over x plus 16. The 16 doesn't matter, really. Now, if there's a negative there, I do have to be careful with the chain rule. So this is going to be, let me fix this, the natural log. Do I need the absolute value? Yes. That's why I kept it in the population problem, because sometimes you don't know, and they do need it here. It's v plus 16 equals negative 2 times what? T. Oh, I should put my little integral symbol in. There we go. Okay, I have 1 point for separating. I've got 1 point for integrating, because you might think it's hard, but it's not that hard. And Noah says, don't forget what? The c. Plus c. I have 3 points out of 5 right now. And unfortunately, if I don't have this right, this whole problem's wrong. So that's why they've kind of changed the problems. They like it so that they try to write it so that if you get this wrong, you still can get B and C. But you can't do B and C if this is wrong. If you don't separate your variables, you've got a 0 on this problem right away. It'd be interesting to see the stats on it. So they've kind of changed how they do that. Okay, now we need to find C, right? And it goes through 0, negative 50. So I'm going to put this in for the P and this in for the T. And you should be ahead of me. Natural log, absolute, and if I don't have an absolute value here, you're going to find a problem here. Can you take a log of a negative number? No. Remember, the domain for the log function has to be positive. And this is 0 plus c. What is the natural log of negative 50 plus 16? What kind of 34? Well, this is negative 34. I want that there. I mean, I'm going to get rid of it because I do have an absolute value. But if you don't have absolute value, you can see, uh-oh, I forgot absolute value. At least I'm hoping it's a little check for yourself. Because it is a stressful exam. It's 4.5 hours. It's 4.5 hours. We get little breaks. So we'll practice taking an exam if we have time. We're going to put that in there for C. So I get the natural log. Now, I can't get rid of that absolute value, and you will see why in a second. Negative 2t plus the log of absolute value of negative 34 is just 34. I am still not done. Now, I got my point for trying to put the values in the right place. So I'm 4 out of 5, and you actually can answer the rest of the question without solving for V. But we're going to do it because we can, and we want that fifth point. What do I have to do to both sides? How do I get rid of logs? It's just like the last problem. E. You see, it's exactly the same as the one I started with. Now it's e to the side. Okay, so I'm going to get this ready. Well, what is this going to do? E to the log cancels out, right? Absolute value of v plus 16 equals e to the minus 2t plus the log of 34. And then, because so many students want to do this, they bring the log of 34 down and they make it e to the negative 2t plus the log of 30, plus e to the log of 34, and it's wrong. So that's a problem. So don't. If you don't know what to do with that, just leave it. It's fine. We can still solve for v without simplifying that. So I will not simplify. Some of you know what it's going to do. It's really going to be this. E to the minus 2t times e to the natural log of 34. What does this give us? It's 34. So it's 34 e to the minus 2t. When you do these exponential ones, when you have this population growth type model, you will never add. You'll never have something added. It can't happen. So on the multiple choice questions, they say, which could possibly be a solution? And they have something that looks like this one up here. No, just throw it out. Not going to work. Never. And I don't use never for always very often. Never, because that's rare that happens. But it will never happen. Okay, take my experience. That's why I'm here. So v plus 16. Now I could put in a positive e. I could do that. Or I could do v plus 16 equals a negative e. Because if I take the absolute value of this negative e to the negative 2t plus the log of 34, that becomes positive. So both of these equations make that sentence true. But only one is going to work. Because if both worked, we would no longer have a what? Starts with an F. Function. So these are functions, right? So taking the top one, I'm going to get v equals negative 16 plus e to the minus 2t plus the log of 34. This is a lot of work, isn't it? Or, I think I can squeeze it in here. V equals negative 16 minus e to the negative 2t plus the log of 34. And some of you are going to say, well, I'm always going to take the positive one. And you can, but you're going to be wrong. How do you know which one works? What's the ordered pair? It must go through 0, negative 50. So if I substitute those values into each of these equations, is negative 50 equal to negative 16 plus e to the 0 plus log of 34? So that's negative 16 plus 34. Is that true? Nope. Okay, Alex? Hope you got that. I put negative 50 in here, now if it didn't make either sure, then I go, oops, I made a mistake. I don't have time. I'm just going to have to turn in my exam like it is. But it's minus e, that's 0 to the log of 34. So this is negative 16 minus 34. Is that true? So this is the answer. You would either circle it or you would cross this one out. They don't like you to circle it, but when here you got to make a choice. If you leave both, you won't get the answer point. You had to choose one. You could flip a coin. It'd be better if you figured out. I think you have to flip your pencil instead. I don't know. Probably not. Okay. That was a lot of work for that fifth point. Do you see why I say if you can't do it, if it's not going to go fast for you, do all the other problems and come back to it later. Okay, this was a calculated problem. You were allowed a calculator in 97 on all the problems on that exam. They've since changed that, of course. Let's do B. B says, now this is terminal velocity. It's the limit as t goes to infinity of v of t. They tell you that. So when you jump out of a plane, there's a certain speed you're going to max out at, and it's the limiting value. So here's my equation. I want to take the limit of this equation right here. We're going to let t go to infinity, and it's only 1 point. And if you just think a little bit, it's not as bad as it looks. First off, what's the limit of negative 16? Negative 16. Now, when you let t go to infinity, what I need to worry about is this piece right there. What's e to the negative 2 times infinity? What does the negative do to my exponential? It puts it in the denominator. What is 1 divided by a very large, large number? That's 0. So this is going to be 0. So the answer is negative 16, and it's 1 point, right or wrong. Put in 100. E to the negative 200 is 1 over e to the positive 200. This is going to 0. I don't even care about the 34. It's irrelevant. This is what's changing in the red. Okay, and then the last part, which everybody really struggles with this, because you really do have to think. There's a subtlety here. It is safe to land when the speed is 20 feet per second. Speed is 20 feet per second. If the speed is 20, what's the velocity? Negative 20. Matt, I think you get a point for saying that. Yes. So my velocity is going to be negative 20, and I'm going to solve this exponential equation I have right here for t. You could go back into the log equation, because I'm going to get there anyway, but I'm going to go ahead and start with that one. So negative 20 equals negative 16 minus e to the negative 2t plus the log of 34. What do we do to both sides? I got to solve for t. What should you do to both sides? Add 16. You have to isolate the term with the t in it. Sorry that this is doing that. What is negative 20 plus 16? It's funny because it doesn't do it until this class. It's negative 4. If you do a positive 20, you're going to run into a problem, because this is negative 4 equals negative e to this. If this were a positive 4, I have to log both sides. I have to log a negative, and that's not going to work. Okay? So I'm going to get 4 equals e to negative 2t plus the log of 34. You were allowed a calculator. Okay, so we're going to log both sides. But we're not going to do a calculator because we're smarter. So it's the log of 4 equals, what's going to happen to that exponent now? It's going to come down, negative 2t plus the log of 34. Maybe we should have a little more practice working with logs. Solve for t. Yes, you could make these decimals, and then you might be happier. But I'm going to subtract the log of 34 because I don't have my calculator handy. I just ran out of batteries. Actually, I did. Okay, so I'm going to get an exact answer is even better. Oh, sorry. So I get the log of 4 minus the log of 34 equals negative 2t. And then some of you are going to say, well, that's going to give me a negative number. No, it's not. Okay. What are we going to do now? Divide by negative 2. And that's the answer. I don't know what it is as a decimal. I'd have to get my calculator out. Can you simplify the log of 4 minus the log of 34? Do you remember the log of A minus the log of B is the log of A over B? It's still whiny. Okay. So it's negative 1/2, and it's the log of 4 over 34 equals t. That's good enough answer. Why is this not going to be a negative time? That's right, but why is the left side not negative? Looks like it's negative to me. Because, nope, no absolute value. Here's the natural log function. This is 1. What's true about the natural log of a fraction? It's negative. It's negative. You could have, there are a lot of ways you can manipulate that. You could take the negative and divide that through, so it's 1/2 times the log of 34 minus the log of 4. Then you'll be happier. Why is this a negative number? Log of 4 is much smaller than the log of 34. Okay, so you got 1 point for saying that the velocity was negative 20, and I believe that you get 1 point like for the setup here, and then 1 point for the final answer. We'll give you this problem again to do. Yeah, it's in the pink packet as well. So, but that's okay. So this is done for Monday now. So the only thing else you have to do is the green, and well, it's not quite time. It's pretty close. Now, should we look at this really quickly? Okay, I'm afraid you're not going to cross multiply and get your variables. All the same kind of variables have to be on each side of the equation. Cannot mix x's and y's. What do we have that's like that you can't mix? Can't mix oil and water.